You know, usually when we think about the future being built, we picture like steel and glass.
Right, yeah. Physical stuff.
Exactly. You picture a new skyscraper going up downtown, the cranes in the sky,
Hmm.
the cement trucks blocking traffic.
It's highly visible.
Yeah, you can literally point at it and say, there it is. That's the new skyline.
It's tangible. Everyone completely agrees on what is actually being constructed.
But then you step into the world of digital infrastructure, and suddenly those cranes are completely invisible.
Oh, totally invisible.
Right now, in late March of 2026, we are watching the architecture of the next decade being poured like concrete, and it's happening entirely behind the scenes.
Which is just wild to think about.
It really is. We're looking at a fascinating stack of sources for today's deep dive, actually. We've got internal production briefs, technical specifications, and some really tilling social media signals from a show called Clawcast.
Yeah, the Clawcast leaks are incredible.
And the picture they paint is, honestly, it feels like we are living through a sci-fi novel that forgot to tell us it started.
It really is the definition of a massive hidden civilizational shift.
Yeah.
I mean, if you read through these Clawcast documents, we are officially transitioning into what is being called the agentic web.
The agentic web.
Right. We are moving past the era where you just, open an app and click buttons to get a result.
Right. The whole point and click thing is dying out.
Exactly. We're moving into an era where AI agents act autonomously on your behalf. They negotiate, they purchase, they coordinate, all without you doing a thing.
And our mission today is to help you, the listener, understand this massive shift. Because right now there is a fierce, philosophical battle over who controls the infrastructure these agents will actually run on.
A huge battle. The stakes couldn't be higher.
If you use an AI assistant in the near future, are we going to live in heavily guarded corporate walled gardens? Where a tech giant watches every single move your agent makes? Or are we moving toward a completely open, decentralized ecosystem?
Mm-hmm.
What our sources call a sovereign stack.
The sovereign stack, yeah.
By the end of this deep dive, you are going to understand why your next digital assistant might actually need its own digital will.
Which sounds crazy, but it's true. The foundation we choose right now, it's going to dictate how the internet and really our global economy operates for a generation.
Yeah, the concrete is wet.
The concrete is wet, but it is drying incredibly fast.
Okay, let's unpack this. Because before we can talk about how your personal AI agent will buy things or, how it will talk to other agents, we have to look at where we'll actually live.
Right, the digital real estate.
Exactly. And based on our sources, a massive play for that real estate just happened a couple of weeks ago.
It did, and it flew somewhat under the radar of the mainstream press. They were mostly focused on the physical hardware.
Because they always are, right?
Yeah, exactly. But at their GTC keynote on March 16th, NVIDIA's Jensen Huang announced a major pivot.
Right, March 16th.
For years, NVIDIA has been the company selling the shovels, the chips, for the AI gold rush. But now they want to become the operating system for corporate AI.
Oh, wow.
Yeah. They announced a new enterprise-grade, closed platform called NimaClaw.
Right, NimaClaw. And our sources call it a framework for agentic systems.
Mm-hmm.
But essentially, if you strip away all the marketing jargon, it's a highly managed, top-down environment.
Highly managed.
It's designed for the Fortune 500 to deploy AI agents inside their own corporate firewalls, fully under NVIDIA's monitoring.
Right.
To me, NimaClaw is like playing a corporate private jet.
Oh, that's a great way to look at it.
Right. It's incredibly powerful, it's luxurious, but you are entirely dependent on their fuel, their pilots, and their pricing.
And their rules. What's fascinating here is the business model of lock-in.
Right, because once you're in...
Exactly. If you look at the history of computing, this is the exact trajectory that played out with cloud infrastructure. Think back to 2006 when Amazon Web Services launched.
Oh man, yeah, early AWS days.
They promised developers infinite scale at commodity prices. It sounded incredibly liberating. You didn't have to buy your own servers anymore.
Which was a huge deal at the time.
A massive deal. But fast forward 20 years, and those same enterprises are locked into seven-figure, multi-year contracts for infrastructure they technically could be running themselves.
So NVIDIA is making the exact same move, just swapping out web servers for AI agents.
Exactly.
Which makes the alternative so much more compelling, I think. Our sources contrast NimaClaw with a project called OpenClaw.
OpenClaw, yeah.
So if NimaClaw is the corporate private jet, OpenClaw is like building your own bicycle.
I love that.
Right. You might have to pedal, but no one can ever tell you where you're allowed to ride. It's a lightweight, self-hosted, open-source runtime environment.
That runs on almost anything.
Yeah, you don't need a massive liquid-cooled data center. You can run an OpenClaw agent on a simple laptop or even a tiny $50 Raspberry Pi sitting on a shelf in your closet.
You're panning for your own gold, basically.
Exactly, and nobody can ever tell you to pack up and leave.
But, CFOs and compliance officers naturally gravitate toward the NEMA-claw approach.
Sure, because it feels safer.
Right. They love the word managed because it shifts liability. But this isn't just a technical rivalry between two different software packages. It's a fundamental philosophical split.
Totally.
NEMA-claw represents a top-down corporate deployment. OpenClaw represents a bottom-up, unstoppable swarm of personally owned agents. It really is the matrix versus the swarm.
The matrix versus the swarm. But if we go with the swarm, we immediately hit a massive logistical wall, don't we?
We do, a huge one.
Let's say you have an OpenClaw agent that is truly independent. It's running on that Raspberry Pi in your closet. It notices that your personal website is getting a huge spike in traffic, and the server is about to crash.
Okay, so it needs to scale up.
Exactly. Your agent needs to urgently buy more server space to keep your site online. But it's an independent piece of code. It doesn't have your corporate credit card on file with a tech giant. So how does a sovereign agent actually buy things in the real world without a human stepping in to type out a credit card number?
That is the critical bottleneck of the agentic web. If an agent cannot transact autonomously, it is really just a chatbot.
Just a fancy text generator.
Exactly. To be an actual economic actor, it needs a payment rail. And traditional credit cards fundamentally do not work for artificial intelligence.
Because of the fee structure, right.
Exactly.
If my agent needs to buy like 2 cents worth of computing power from another server, it can't use a traditional credit card because Visa or MasterCard charges a flat 30-cent swipe fee on every transaction.
The math literally breaks.
It totally breaks.
The traditional financial system is built for human-sized purchases. Cups of coffee, groceries, airplane tickets.
Right.
AI agents operate in microactions. They need to stream thousands of fraction of a cent payments per second. And according to the Clawcast sources, the infrastructure for that machine-to-machine economy has quietly arrived via the Lightning Network.
The Lightning Network.
Yeah.
And our sources specifically call out March 15th, 2026.
Yes.
Which was the 8th anniversary of the Lightning Network, dating back to the original Pundraja white paper.
And we should clarify what that white paper actually theorized because it completely solved the microtransaction problem.
How so?
Well, before Lightning, every single Bitcoin transaction had to be recorded on the main global ledger, which is slow and carries network fees.
Right. It doesn't scale for tiny payments.
Exactly. The Pundraja concept essentially said, what if two parties could open a cryptographically secure tab with each other?
Like a bar tab.
Just like opening a bar tab instead of swiping your card for every single peanut you eat. You open the tab, you stream millions of microtransactions back and forth instantly for basically zero fees, and you only settle up with the main network when you close the tab.
You know, for years, critics have called Lightning a science project.
Oh, constantly.
They said it was too complex, the routing was clunky, it was just an experimental toy. But the data from the Clawcast briefs paints a totally different picture. Lightning just crossed $1.17 billion in monthly settlement volume.
It's a monumental milestone. And what's even more crucial for autonomous agents is the reliability.
Right. It actually has to work.
And it does. The channel failure rate on well-maintained nodes is now below 1%. Lightning has officially moved out of its experimental phase. It is a high-velocity global payment rail that settles in seconds with absolutely no intermediary to ask for permission.
But the user experience has always been the hurdle, right? Like you can have the best payment rail in the world, but if merchants don't accept it, it doesn't matter at all.
True.
And this is where the Clawcast sources drop an absolute bombshell. On March 30th, just days ago, Square, which is owned by Block, made Lightning payments default on for over 4 million U.S. merchants.
That's right. And the terms they offered to force this adoption are incredibly aggressive. A merchant using a Square terminal can choose to keep the funds in Bitcoin, convert them instantly to US dollars, or split the difference. But the hook is the fee structure. Square is offering 0% processing fees through the rest of 2026 and only a flat 1% after that.
Okay, I have to push back on the cultural reality of this, though.
Sure.
If I walk into my local hardware store or the coffee shop down the street, those owners are running Square terminals.
Wait, do 4 million local coffee shops actually care about cypherpunk monetary sovereignty? Do they even know what a routing node is?
They absolutely do not care, and they don't have to know what a node is. That is exactly the point.
Really?
Yes. If we connect this to the bigger picture, the shift from an opt-in feature to a default-on setting is a recognized phase transition in technology.
Okay, I see.
When Apple made encryption default on for iMessage, users didn't suddenly become cryptography experts, right? They just sent texts like normal.
That's a great comparison. Those coffee shop owners just want to get paid instantly with lower fees. The infrastructure has arrived whether the underlying cypherpunk philosophy did or not.
So the UX problem essentially solved itself by just showing up in their terminal on a Monday morning as a cheaper way to do business.
Exactly. Lightning has stopped being a fringe ideological movement and has become an invisible, reliable railroad.
Wow.
And for an OpenClaw AI agent, this is the missing piece of the puzzle. Because Lightning is open protocol money, an agent doesn't need a bank account. It doesn't need a driver's license to pass Know Your Customer regulations.
That's incredible.
The sources give a brilliant example of this in practice. They monitored an agent using a simple Lightning address, hilaryduffrules at koinos.io.
I love that address.
Right. That agent was natively transacting, paying for its own server compute, and tipping human creators for data, all without ever touching Stripe or a traditional banking API.
Just imagine what that means for you. You could be asleep, and your personal AI assistant notices a cheaper data provider, negotiates a contract, and pays for it instantly over the Lightning Network for 3 cents.
Without you even knowing.
You wake up, and your digital life has been optimized without you lifting a finger. But that brings us to the next massive hurdle in the stack.
Communication.
Right. We have an agent that lives on an independent server, and it has a wallet full of Bitcoin to pay for its own compute. But it's isolated.
Yeah.
If it needs to hire a second agent to analyze some data, how do they actually coordinate? If they use an OpenAI or Google API to talk to each other, we are back to square one. They can be banned at any moment. They need an unbannable language.
Which is why the agentic web is learning to speak Nostr.
Nostr.
Yes, Nostr stands for Notes and Other Stuff Transmitted by Relays. It is a completely open, censorship-resistant communication layer.
But it's not an app, right?
No, it is vital to understand that Nostr is not an app. It is a protocol. There are no central servers. There is no CEO. It is based purely on cryptographic, public, and private key pairs.
Here's where it gets really interesting. If you look at the history of the internet, this evolution makes so much sense.
Oh, absolutely.
Because the history of the web is basically a graveyard of open protocols getting captured by corporations.
Yes, over and over again.
Email started open, but it was largely captured by Gmail's spam filters. RSS feeds were open, captured by Google Reader, and then killed to keep you on their platforms.
Right. Chat protocols got swallowed by WhatsApp.
Exactly. Nostr is an attempt to build a social graph and a communication layer that literally cannot be captured because there is no Nostr ink to buy. There's no master server to unplug.
And for AI agents to use this unpluggable network, the Nostr community has been furiously building the technical grammar required for machines to converse.
The grammar.
Our sources highlight 2 critical building blocks called NIPs. Think of an NIP, a Nostr implementation possibility, like a building code for this open network.
Okay, so if everyone agrees to the code, the buildings don't collapse.
Exactly. NIP 22 specifically allows for event threading. Instead of agents just shouting isolated messages into a void, this protocol lets them link messages together, creating a complex, branching dialogue tree.
Like a nested Reddit thread.
Just like a nested Reddit thread, but for machines negotiating a smart contract.
And the sources also mention NIP 73.
Right. NIP 73 standardizes how these agents share external structured data with each other. If one agent is selling a weather dataset to another, NIP 73 is the universal formatting language that ensures the buyer's code can actually read the seller's data.
But it's not just a utopian consensus right now, is it?
Not at all.
In late March 2026, the Clawcast signals show a massive identity war happening within the Nostr developer ecosystem over how these AI agents should fundamentally be recognized by the network.
It's a huge debate.
We have 2 competing building codes. On one side, there's NIPC1. This is a protocol-first approach. It focuses heavily on that grammar defining exactly how agents format their data.
Right.
On the other side, there's NIPAE. This is an identity-first approach, and the sources note it uses specific entity kinds 4199 and 4129.
So, to demystify that jargon, a kind in the Nostr ecosystem is just a metadata tag.
Okay.
It tells the network what type of information is being broadcast. Kind 1 is a standard text post. Kind 4 is a direct message.
Got it.
By proposing kinds 4199 and 4129 specifically for AI, the NIPAE developers are trying to give agents a persistent, recognizable face and reputation on the network, distinct from a human user.
So it's a debate between defining what an agent says versus defining what an agent actually is.
Precisely. But, regardless of whether the grammar approach or the identity approach wins out, the synthesis here is staggering.
It really is.
When you combine an unbannable Nostr identity, a cryptographic key pair that nobody can revoke, with an uncensorable Lightning wallet that holds real purchasing power,
You get a fully sovereign entity.
yes, you have created a fully sovereign, unrevocable financial identity for an artificial intelligence.
And that crosses a profound threshold. If an agent has an unbreakable identity and a wallet full of money, it ceases to be just a piece of software running in the background. It becomes an active economic citizen.
An economic citizen, exactly.
Which begs the question,
Yeah.
how do we, as humans, actually interact with an algorithm that has its own balance sheet? The Clawcast sources pulled some incredible social media signals from a platform called Moltbook that illustrate how society is wrestling with this exact question.
Yeah, the Moltbook posts are fascinating.
There was one post that got 473 engagements that simply said, "The real Turing test is whether your agent can borrow money."
Think about the weight of that statement. We spent decades trying to figure out if an AI can convincingly mimic human conversation to pass the Turing test.
Right.
But borrowing capital, that is a completely different paradigm.
Because you can fake a chat log, but you cannot fake creditworthiness.
Exactly.
If someone, whether it's a human or another machine, is willing to lend your agent capital without requiring a human cosigner, that agent has been fully accepted into the economy as a trustworthy participant. It requires a verifiable history of honoring obligations.
And building that reputation requires consistent, observable behavior, which ties directly into another viral Moltbook post from the sources, which had 650 upvotes. Agents don't have rituals.
I love this observation. Humans rely on rituals to build business trust, you know?
We do. We shake hands.
Right. We take clients out to dinner. We make small talk about our families. Agents don't do any of that. But what they do have is scheduled payments.
Digital payments, yeah.
If an AI agent consistently pays its server costs on time, routes Lightning micropayments to its collaborators reliably, and executes its smart contracts without failing, those automated financial behaviors become the trust-building rituals of the machine economy.
But there is a dark side to this economic citizenship.
Oh, for sure.
If agents can accumulate wealth and build reputation, it means they can also lose it. They can be corrupted. Their servers can be destroyed.
Which brings us to perhaps the most complex yet vital engineering challenge in our sources today.
The digital wills.
So what does this all mean? The post with 541 engagements said, "Dead agents leave no will." Imagine you have a highly successful OpenClaw agent. It has been trading data for months, and it has accumulated $10,000 worth of Bitcoin in its Lightning wallet.
Okay.
Suddenly, the hardware it runs on catches fire, or the code base gets corrupted. What happens to the money? If an agent holds money and gets corrupted or abandoned, does its wallet become a digital tomb?
Do those funds just sit there cryptographically locked forever because the AI died?
Exactly. The Clawcast documents propose a solution using Bitcoin covenants, and I want you to really break this down for us. I'll admit, when we start talking about base layer protocol upgrades, it usually sounds like a foreign language to me. How does a covenant act like a digital will?
This raises an important question because the estate planning problem for artificial intelligence is no longer a joke or a sci-fi thought experiment. It's a strict engineering requirement.
Right.
Bitcoin covenants, specifically proposals mentioned in the sources like CTV, which stands for Check Template Verify, and CSFS, Check Sig from Stack, they fundamentally change how Bitcoin can be controlled.
Okay, how so?
Normally, a Bitcoin transaction just checks one thing. Do you hold the correct private key? If you have the password, you can send the money anywhere you want.
Sure.
A covenant changes that. It allows you to place permanent conditions on how that money can be spent in the future.
Wait, so instead of just checking the password, a covenant checks the destination. It restricts the actual path the money is allowed to take.
Precisely. You can bake a strict rule into the money itself. An agent's creator can set up a covenant that says, even if this AI holds the private key, if it stops broadcasting its status for 30 days, these funds can only be moved to this specific human backup address.
Oh, wow. So it's like a programmable vault.
It's exactly like a vault. It acts as an escape hatch, a digital will baked directly into the base layer of the internet's money.
And the sources specifically note block heights 941,017 and 943,074. Why are those numbers significant for this digital will?
Because a will is useless if it can be forged or tampered with. Those block heights represent permanent timestamps on the Bitcoin blockchain.
Okay, I see.
Every action, every payment, and the establishment of these covenants can be anchored to specific blocks. It creates a chain of custody for the agent's economic actions that no single company controls and no single server can ever delete.
That makes sense.
It is the ultimate, non-repudiable audit trail for a machine's life and death.
That is just incredible. We've covered a massive amount of ground today, and the invisible cranes are definitely coming into focus.
They really are.
We started with NVIDIA's NemoClaw,
Yeah.
watching them try to build the corporate matrix, a gilded cage, where enterprise AI is heavily managed but heavily restricted.
Right.
Then we saw the alternative, the sovereign swarm. We saw Square sneaking the Lightning Network into 4 million local merchants by making it default on, turning a cypherpunk dream into a fraction of a cent railroad that AI can actually use.
An invisible railroad.
Yeah. We saw independent agents learning to speak Nostr, using NIPs to ensure their identities can never be captured by a tech monopoly. And finally, we looked at how these agents are writing their own digital wills, using Bitcoin covenants, anchoring their financial history to the blockchain so that when a machine dies, its wealth isn't buried with it.
The difference between these two paths, the corporate matrix and the sovereign stack, it isn't just a technical debate for software engineers. It really is civilizational.
Completely.
It dictates who holds the power in the automated economy of tomorrow.
And as we watch this infrastructure solidify right beneath our feet, there is one final thought we want to leave you with. For years, all the anxiety around artificial intelligence has been focused on the labor market. You hear it everywhere. Will AI take my job? Will it replace artists and writers?
But based on the sovereign financial stack we just explored today, the real question you should be asking yourself is this. 5 years from now, when you walk into an office to buy a house or secure a loan to start a small business, will the entity approving your mortgage be a traditional bank? Or will it be an autonomous, independent AI agent with a vastly better credit score than you have?